So, very good morning. Welcome to the course of electromagnetics. In electromagnetics, in early days, electricity and magnetism were considered as unrelated phenomena. So, we can say that there is no direct relation between electricity and magnetism in early days, but as time progressed, the relationship between electricity and magnetism the relationship between electricity and magnetism became evident, and the word electromagnetism emerged. So, in today's world, we hardly find any electrical or electronics devices around us which does not work on the principle of electromagnetics or not influenced by these principles. So, so electromagnetics is the study of interaction of fields. Electromagnetics is the study of an interaction of fields. Field may be electric field or magnetic field. This field is generated by a time varying charge distributions and current. So we can say that if we have a time varying field, then time varying field will generate electromagnetic wave. So the next question comes in our mind: why we study electromagnetics? In certain situations, circuit theory fails to give the correct answers, so the electromagnetics is necessary to be invoked. In this question, we have a signal source. Source may be battery, battery or time varying source. This is switch. At t is equal to 0, we close the switch, and this are two long wires, and the other end of this wire is open circuit. So at t is equal to 0, we close the switch. One can possibly come with different answer. The first of answer can be nothing will happen, since the circuit other end is open circuit, so no current will flow in this loop, so the nothing will happen to this circuit. We can say this thing from the circuit background point of view. And the second one can say, since the problem is not completely defined, since the length and the shape of wire is not specified, we have not given this length of wire, what is the length of wire and what is the shape of wire, this is not specified. Also the frequency of operations, means at what is the signal frequency we have used at the source end, this is also not mentioned. So one can say that the problem is not completely defined. From the circuit background, we already say that nothing will happen, since this is open circuit, no current will flow, uh, flow, so nothing will happen. And the next option is current will flow for a short period of time. From earlier physics courses, we might say that wire will be charged, and current will current flow during the charging process. What So the next questions comes in our mind is, what process charges wire, what will be the shape of current waveform, again does the frequency of source matter in this case. If you are trying to answer these questions, so we are unable to answer these questions from the circuit theory or circuit viewpoint. For that purpose, electromagnetics is necessary. So we can say that we need to know something else beyond the circuit theory to answer these questions of the charging process, the shape of current waveform formed, and how long the charging current will flow. And the next one is output depends on the length and shape of wire. For this purpose, if we bend the wire at this point, due to this bending, anything happen to the circuit? To analyze that, we have connected a source and T is switch. As T is equal to 0, we have closed the switch and wire is bent at this point. Wire is bent is that at this point, and a resistor is connected, and to view the waveform we have connected oscilloscope. At T is equal to 0, switch is closed. At T is equal to 0, switch is closed. The circuit person will say that this length of wire, just because it is bent, doesn't does not really mean anything. The voltage we have applied at this point, same voltage will appear at resistance R, and the same voltage will display on the oscilloscope. So if we have sinusoidal input, then output also sinusoidal in nature. Output also sinusoidal in nature. However, if we increase the frequency, at very high frequency, this bending will cause a voltage drop across this resistor, and this voltage drop will be 0 at high frequency. This is something that cannot be understand from the circuit viewpoint, and this bent wire is equivalent to straight wire in case of circuit analysis. So this bending, if we say that electromagnetic person will say that this bending will behave as inductor at low frequency, and this bending will affect as a transmission line at high frequency. This concept cannot be, and this concept are not developed from circuit theory, and then we have to answer what is inductor, how we calculate the inductance. These are the questions. The next one is, in circuit theory, the length of interconnect between the circuit element do not matters, but in case of electromagnetics, this will matters. Also the shape of wire also matters. If we consider this is a wire and we have connected a parallel plate between these 2 points. These two plates are connected. Through a resistor, and we have connected a source at this point, and this resistance is connected to oscilloscope. And this is metal plate act as a capacitors after volt. So the length of wire, if we consider the length of wire, suppose we have two wire and source is connected at point A dash, and we have connected oscilloscope at the other end. Oscilloscope at the other end, and the length of this wire is L. Suppose we have considered the length of wire is L. If we applied voltage at point A dash, then what will happen? Same voltage will appear at point B dash, or it will take some time. So same voltage will experience at this point, at point B dash. Suppose if the length of wire is approximately 1 kilometer, 2 kilometer, 3 kilometers, or in order of kilometers, then this does not matter in case of circuit analysis, but from electromagnetic point of view, the length of wire matters. Suppose we have applied a sinusoidal signal and the shape of signal is like this. At t is equal to, we find the maximum amplitude, and this is frequency of operations. At t is equal to 0, here we find the maxima, and the maximum voltage will go through this wire, and if we look at the output side, the maxima will not appear at point at t is equal to 0. It takes some time. This time is L upon B, length upon velocity, and we obtain the maximum at this point. So we experience some kind of delay when we are using a long transmission line. If source and load are separated by a very large distance, so we can say that if source and load are separated by a very large distance, then there is some delay involved, and this delay is not taken into account by circuit theory, whereas this is explicitly taken into account by electromagnetic theory. So circuit theory, we generalize circuit theory as a lump parameters. Circuit theory modeled as lump parameter, models, or we can say lump circuit modelings. In lump circuit model, we simply neglect this delay. In lump circuit, the time delay due to wire, no matter how small the length of wire, causes a phase shift of causes a phase shift of voltage and current wave, and we neglect this phase shift if the length of wire is if the operating wavelength is much less than the length of the wire. Thank you.